My name is CHUN. Today I would like to present my PSM project. Introduction. Magnesium alloy is a combination of magnesium mixed with aluminium, zinc, manganese, silicon, copper, rare earth metal, and zircon to improve the physical properties. It is lightweight and has low density. It's suitable to be used in manufacturing, automotive, and aerospace applications due to their low density and high specific strength. The material they use in this study is magnesium alloy AZ31B. Problem statement. Magnesium alloy AZ31B could replace raw homogeneous armor RHA due to its impact behavior. However, the composition of AZ31B is insufficient to support energy absorption that will cause this material to be fractured. It also has low mechanical strength and poor ductility. Therefore, heat treatment and quenching process is needed. The purpose of this project is to study the microstructure and mechanical properties of magnesium alloy AZ31B after quenching in the medium that contain nanoparticle, which is graphene oxide. Objective: to evaluate the effect of various temperature of heat treatment towards the microstructure and tensile properties of magnesium alloy AZ31B. Next is to evaluate the effect of various weight percentage of graphene oxide medium towards the microstructure and mechanical properties of magnesium alloy AZ31B. Scope: the material that used in this project is magnesium alloy AZ31B with the heating temperature of 250 degrees Celsius and 350 degrees Celsius. The quenching medium they use is a combination of distilled water with graphene oxide at various weight percentage and medium like A and distilled water as control parameter. Energy dispersive X-ray spectroscopy or called as EDX analysis will be conducted to see the microstructure of magnesium alloy AZ31B to identify the presence of graphene oxide at the surface of the material and determine whether each specimen consists of graphene oxide or not. Tensile tests will be conducted to test the energy absorption of magnesium alloy AZ31B to mention how much it can be deformed before it fractures. Literature review. The material they use is magnesium alloy AZ31B. The word AZ stands for aluminium, zinc, manganese, while 3 and 1 is the weight percentage of aluminium and zinc, and B is the second composition which has registered at American Society for Testing and Material as called as ASTM. Magnesium alloy AZ31B is a rope ion alloy that belongs in AZ series with high concentration of aluminium and zinc. It has 97% of magnesium, 2.50 until 3.50% of aluminium, 0.6 until 1.4% of zinc, minimum 0.27% of manganese, 0.10% of silicon, 0.031% of copper, maximum 0.005 iron, and maximum 0.005% of nickel. The advantage of magnesium alloy AZ31B is it has high boiling point and good machinability. It also used in automotive, modern aircraft fuselage, cell phone and laptop cases, speaker cone, and concrete tools. However, it has disadvantage. It has low energy absorption and low mechanical strength. Therefore, heat treatment with temperature of 250 and 350 will be used for this material. After the heat treatment process, it will be immersed in the medium that consists of nanoparticles like graphene oxide. These are the physical properties and chemical properties of magnesium alloy AZ31B. Heat treatment. It is a process of heating the material in solid form and cool it in a controlled way to obtain the desired mechanical properties without changing the composition of the metal. It will modify the structure of the metal to become more stronger, more reliable, resistant to abrasion, and increase in ductility to make it become more wearable in machining. There are three stages of heat treatment, which are heating stage, soaking also called as holding stage, and finally is cooling stage. There are heat, five heat treatment techniques, which are annealing, normalizing, hardening, tempering, and annealing. When magnesium alloy AZ31B carry out heat treatment process, it will reduce weaknesses, improve mechanical properties of a metal by changing the structure of crystal and eliminating imperfection in microstructure. It will also improve hardness value to prevent the metal being fractured. However, heat treatment is difficult to be controlled when material reach high melting point at 650 to 1050 Fahrenheit or 340 to 565 degrees. This will make the material become soft, and finally it will cause the defect. So these are the picture of heat treatment, and another one is the graph temperature versus time for heating, holding, and cooling. And these are the figure that show the defect of heat treatment process, which is stress corrosion cracking SCC of magnesium alloy AZ31B. Therefore, a quenching process is needed. Quenching process. It is the process of soaking of material at high temperature that above recrystallization phases, followed by a rapid cooling process to adjust the mechanical properties of its original state. Air, water, oil, and brine are the example of conventional quenching. However, this medium does not have specific cooling characteristics. For example, water is the popular quenching medium because it is cheap and easily to be found. It has high cooling rate to be quenched for carbon steel. However, when facing the hot metal steel, the bubble will be come up and this bubble will cause cracking or wrapping. Therefore, quenching in medium that consists of a graphene oxide is a good way. Graphene oxide is a structure that consists a single atom layer with some functional group such as carboxyl acid, hydroxyl, and epoxy. It has high tensile strength and easily to be dissolved in water due to the plenty of oxygen that contained in graphene oxide. When magnesium alloy AZ31B quenched in medium that consists of nanoparticle, the graphene oxide will fill in the void between the atom to produce the vanilla. So this will increase the mechanical properties. Next is methodology. These are the flow of the experimental of magnesium alloy AZ31B. First, the solid wood will draw the donut shape. Then the laser cutting machine will cut the donut shape on the raw material of AZ31B. After that, the AZ31B will be carry out the heat treatment process with 250 and 350 degrees Celsius for 3 hours. After the heat treatment process, it will be carry out the quenching process for 30 minutes. The medium that used in the quenching process is A. Distilled water. Distilled water plus 0.1% weight of graphene oxide, and distilled water plus 0.3 weight% of graphene oxide, and distilled water plus 0.5 weight% of graphene oxide. After the quenching process, microstructure analysis will be carried out. In microstructure analysis, that consists of SCM analysis and EDS analysis. After that, it will carry out the tensile test analysis to test the ultimate tensile strength and yield strength and then the young modules of magnesium alloy AZ31B after the quenching process. Sample preparation. First of all, magnesium alloy with dimension of 200 mm times 200 mm times 2 mm will be bought at the Lazada. Then a solid software is required to draw the dome bull shape by referring to the ASTM standard E8-04. Then a laser cutting machining will be used to cut the dome bull shape at the magnesium alloy plate. After the dome bull shape was being created, it will carry out the heat treatment and quenching process. The machine that will use is Nabeta heat treatment furnace. This furnace will be preheat at 5 minutes. Then the sample will place at the brick to prevent damage to the furnace. After that, heat treatment process will be carried out at 250 and 350 degrees Celsius for 3 hours. Then it will carry out the quenching process by soaking the sample in 5 different medium for 30 minutes. To get the solution that consists of graphene oxide, using ultrasonic probe to dissolve the graphene powder in distilled water until the necessary amount is reached. Then, using probe type ultrasonic processor Q Sonica 700 sonicator and ice pump to do the sonication at 20 kHz for 15 minutes. To calculate the volume of solvent, you can use this equation. These are the picture of the heat treatment machine that we'll use and the heating profile of AZ31B. And then these are the table of the specimen. After the quenching process, the microstructure analysis will be carried out. There are two types of microstructure analysis, which are SCM analysis and EDS analysis. SCM analysis is used to see the microstructure of magnesium alloy AZ31B. The machine that we use is scaling electron microscope SCM Genesis Evo 50. To do this process, first need to take a small piece of the sample and place at the mount. Then click when and place the mount under the vacuum chamber. Electron gun will create high electron beam. Even hard Tony detector will gather all the signal and the microstructure of AZ31B will shown at the screen in 2D intensity map. Next is EDX analysis. It is used to determine the presence of graphene oxide. Either it has a lot or only a little bit due to the parameter that has set, which are the weight percentage of graphene oxide in quenching medium. EDX is made up of 3 basic components, which are emitter source, a collector, and an analyzer. Finally is the tensile test analysis. It is used to investigate the ultimate tensile strength, yield strength, and young modulus of AZ31B after heat treatment and the quenching process. The machine they will use is Shimazu Autograph AGX Plus. To do this analysis, first need to turn on the power supply and the PC. Then place the sample with the dome bull shape at the tensile test jig. Then create a test method and put all the parameters that require dimension of the dome bull shape and then the force that needed. After that, we'll start the testing. After finish the testing, we'll save all the result, then turn off the power supply and PC. These are the machine that used in the tensile test, and these are the tensile test jig. Preliminary result. So these are the drawing that I had drawn at the SolidWorks by referring to the ASTM standard E8-04. I also made some estimation to know how many pieces of dome bushel will be created at the 200 times 200 times 2 mm of magnesium alloy plate. That's all for me. Thank you.